So 16E is kind of teaching us kind of a trick, I guess. It's just a way that we can manipulate integrals that have more than one function. So consider the integral. This is to the fourth times this. There is no product rule for integrals. There is no special rule, but we do have integration by substitution. You can recognize this typically when you see one function times the other. The other thing I want you to pay attention to, if you did the derivative of the inside of this part, what's the derivative of x squared plus 3x? Anytime you can take the derivative of one part and see that in the integral, that's indicating that you're going to use integration by substitution. So there's this great big long process. I'm not going to worry about this. What we're basically going to do is turn the integral of f of x into f of u. All right, so for example, using this problem here, typically you want to look for what's inside a power, and we're going to set that equal to u. So we choose u to be the inside. It could be inside of a power, inside of a radical, inside in the denominator, in a trig function, all these different things. And we'll look at all of this. So you choose your u, then you take the derivative. So rather than say, so typically we would say the derivative of u with respect to x. So we take the derivative of the right side. What we end up doing is moving the dx. It's kind of like you multiply both sides by dx. Our goal is to turn every x in the original problem into a u. So we're going to bring down the integral. Notice this here is u. We're substituting u in place of x squared plus 3. This is to the fourth power. And then what is this? 2x plus 3 times dx is this whole thing. And so I replace it. I substitute du here, and I substitute u here. So where this is all in terms of x, I'm going to replace everything with some sort of u using this guide over here. Now this just turned into an easy problem. When we integrate u to the fourth, use your power rule, add 1 and divide, plus c. So we change into u, integrate, and then we go back to x. So what is u again? Come back up here. U is x squared plus 3x. Everything else stays the same. So your goal is to substitute to make it an easy integration, do the integration, and sub x back in. All right, so let's check this one out. So we see multiple quantities. We see this part and we see this. You choose your u, and one way to look at it is pick the one with the highest exponent, because when you choose your u and you take the derivative, your du is going to be the other piece. So when I take the derivative, 3x squared plus 2x, then we always just put the dx at the end because I need it to be connected up here. So instead of having it under the du, we just move it to the other side. All right, so everything, we now just substitute our u's in. This is the square root of u, or u to the 1/2. And this whole thing is the same thing as du. Add 1, divide by 3/2, which is multiply by 2/3, plus c, and then replace the u back with what it equals. You guys might need, this might not make perfect sense to you, and that's okay. This takes a little processing. So even if we need to come back and redo the notes or just work through a lot of problems, that's fine. Because once you see it, it's not that bad. Okay, so we have two things being multiplied. We have the x and we have the e to the x. Typically, if you have two things being multiplied with e, look at the exponent of e. And can we manipulate this to create this situation? So what's the derivative of the side is negative 2x dx. All right, so I'm going to kind of work through this. First of all, I'm going to switch the order here because the order doesn't matter when we're multiplying. This has to do with my u. Does this totally match over here? See how I have x dx here? Anything extra over here, we will divide by. So I'm going to divide both sides by -2 because I want to get this to match this. That's our whole goal. You find your u, you take the derivative and manipulate it until it matches this. All right, so we keep the e. You always keep the e. There's nothing you can do about that. What's in the exponent? This exponent is my u times. Now, this whole thing is taking the place of x dx because this side equals this side. But this -1/2, I'm just going to move it all the way to the front so it doesn't cause any issues. We're just going to put it out front and it just turns into a constant. And then I can bring down the du at the end. So what's really important, remember my illustration of pitcher and catcher? The function, the batter always needs to be in between the pitcher and the catcher. You could put any constants on the outside though. All right, so now we're ready to integrate. So just bring down the constant. The antiderivative of e is just e plus c, and then substitute back your u. All right, so where you see a lot of different trig stuff, first of all, I would rather have my integration symbols. When you see cosine to the third, typically what you want to do is you're choosing the part with the power, but you don't use the power. With the trig stuff, choose the part with the power, but you don't use the power. So my u will be just cosine. So then my du is negative sine x dx. Now be very careful. With integration, we're doing, or with substitution, we're both doing derivatives and antiderivatives. Make sure you're using your formula booklet, that you're not doing silly mistakes. The derivative of cosine is negative sine. Then we're going to substitute. All right, so cosine to the third, since cosine is my u, that's u to the third, sine x dx. Notice the sine x dx is here. I don't have that negative. So what I do is I move it to the other side, which makes this negative, and du goes at the end. If that's not sinking in, don't worry about it. We'll work through that in class. Antiderivative, I'll bring the negative down, u to the fourth over 4 plus c, and then sub cosine back in. Now, what I'm going to do, rather than having the 4 underneath cosine, I'm just going to move that 4 to the outside, cosine to the 4th, x plus c. Now, what's very important, you're integrating with respect to x. You must take and convert back everything to x, so be really careful about that, okay? And as always, don't forget your plus c. All right. If you have a fraction, if you're dividing two functions, you're always going to choose the denominator as your u. And this is why. Technically, the dx is in the numerator with the cosine, so that this needs to be the du. So that's why you always choose your u to be on the bottom. So if I choose u to be sine of x, du is cosine x dx, then you can see how this matches. All right. So since this whole thing is the du, I'm going to put the du at the end, put a 1 to hold that place. Sometimes you will see, oops, hang on. Sometimes what you'll see is du over u, but that can be a little confusing. I like to see the du at the end where you see this is the batter. This is the in between, the function you are integrating. All right, so what's the antiderivative of 1 over u is ln u plus c. I think this is the hardest antiderivative to recognize because it's the only power in the denominator that you don't move up. You have to just recognize it's ln. That's why I keep saying, keep your formula booklet handy. All right, and always use absolute value when you're doing ln. Convert back to x plus c. So your final answer needs to have converted back to x plus c. And there's homework.